Hello and welcome to another video. Today I'm doing a GCSE Maths breakfast warm-up. This is preparation for paper 2, paper 3. So this is written on the after having seen the paper 1 material. So I've pitched this at the hot topics for paper 2, paper 3. Attached to the description to this video, you can find a link where you can download a copy of this sheet. I'd recommend this as kind of the final prep before your exam. If you have the opportunity to do that as a face-to-face with your teachers, though, that's going to be better because they can give you individual help. But if you're unable to make that, I'd strongly recommend this as a final bit of prep before your exam. This is written for the June 25 series, and this is for the higher tier. And if you find this video useful, please do subscribe and you will get notified as soon as any of my other material becomes available. I'm going to be working on your paper 3 topics very shortly. Okay, so here's the whole sheet. I'll zoom in to make each question a bit more viewable. Right, question, and I'll do them a row at a time. So I'll do the number ones first, then the algebra, and so on. So convert 4.3 times 10 to the 6 into ordinary number form. So I'm in effect moving this decimal point 6 places to the right. So that's going to become 4, 3, and then I need to move it. So that's moved it one place. I need to move it 5 more places. So 1, 2, 3, 4, 5. So that's going to be my number, 4,300,000. A number n is a cube number and an even number. So n is the cube number. Give an example of nn, or n times n, or n squared. Right, so if n is a cube number, if we think about our cube numbers, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and then 4 cubed is 64. So we're after an even version as well. So those are my two first ones. There will be others. Give an example of n times n. So I'm going to say that if n is equal to 8, then 8 times 8 would be 64. We'll give the other version then. So we could do 64 cubed as well. This is a calculator practice, so we can use our calculator. So if we do 64 squared, or 64 times 64, 4,096 would also be fine. Next one would be 6 cubed. 6 to the power 3 would be equal to that. And then if we wanted that number squared, that would be another fine one. But I'm going to stick with, I would probably go 64, keep it nice and simple. Find the highest common factor of 48 and 64. So on a calculator paper, the most straightforward way, you can find the highest common factor on a calculator paper, but I always find the easiest way is to just view it as a fraction. And then whatever it simplifies down by is the highest common factor. So it's simplified by to 3/4, which means 48 divided by 3. It's simplified down by 16, so the highest common factor would be 16. Right, increase 35, 300, increase 250 by 35%. So I'm going to, if I want to increase by 35%, that's a multiplier of 1.35. So we can just do 250 times by 1.35. So if I do 250 multiplied by 1.35, that gives me 337.5. 337.5. Just checking it wasn't pounds or anything like that, so we don't need a unit. And just checking I've typed everything in right. Okay, the error interval for number x is 3.7 is less than or equal to x, which is less than 3.8. What is the maximum possible value of x? So x times x. So I'm going to take the maximum value here. So I'm going to do 3.8 times 3.8. So 14.44. Technically, in terms of bounds, that would be okay. We could see an argument for saying that it's 100 and, sorry, 14.439 reoccurring. Be arguably acceptable as well. Right. For our algebra, solve for x. 3x squared minus 5x plus 2 is equal to 0. Okay, so what I'm going to do is I'm going to see whether this will factorize. We've got prime numbers here and here, so we've not got a huge amount of options. It's got to be a 3x and an x, because that's the only way that we could make 3x squared. And then can I arrange the 2 and the 1 so that I get a minus 5? So if I did, let's say, minus 1 here, that would give me 3. Minus 2 there would give me minus 5. So that's going to be my factorized version. And then if I'm pulling off my two values of x, then to make this bracket 0, x would need to be equal to 2/3. And then to make this bracket 0, x would need to be equal to 1. So that's going to be my values. Right, expand and simplify. So expand first. So 2x times by x would give us 2x squared. 2x times by plus 3 would give us plus 6x. Minus 4 times by x would give us minus 4x. And then minus 4 times by 3 would give us minus 12. Middle two terms can then be simplified. So I'm just checking that I've done that right. 2x squared plus 6x minus 4x and then minus 12. Yeah. So that's going to be simplified then. 2x squared plus 2x minus 12. Right, change the subject to the formula. Y is equal to 5x minus 2 to x. So we want to get the isolate x. So my first step is going to be to get rid of my minus 2. So I'm going to do that by adding 2. So y plus 2 is equal to 5x. Then I'm going to divide both sides by 5. So y plus 2 all divided by 5 is equal to x. And then x is now the subject. That would be fine, but if I'm asked to make x the subject, I like to write with the x on the left. Although it's not incorrect to have not done it, I just prefer to do it. Right, solve the inequality. So in a similar fashion here, I'm going to view it like an equation where I'm going to keep my inequality symbol as the kind of the equal sign. So I'm going to minus 3 from both sides. That will give me 2x has to be less than 8. And then divide both sides by 2. X has to be less than 4. And then the final one in this row, find the gradient and the y-intercept of the line. So if it's in the form y is equal to mx plus c, m is the gradient and c is the intercept. So I'm going to rearrange this equation to get it of that form. So I'm going to start by adding 10x on both sides. That will give me 5y is equal to 10x plus 15. Then if I divide both sides by 5, I get y is equal to 2x plus 3. So the gradient for m is going to be equal to 2. And the intercept on the y-axis, c, is going to be 3. Right, calculate the area of a sector with a radius of 8 centimeters and a sector angle of 60 centimeters, 60 degrees. Use pi is approximately equal to 3.14. That's fine to use. I'm going to use my calculator though. That was just kind of if you didn't have a calculator. So the area of a sector is going to be equal to the angle divided by 360 times by pi r squared. So in this case, that's going to be 60 over 360 times by pi times by 8 squared. So that'll give me 1/6, but just if I wasn't confident with that, I can type it in just like that. I'm going to say times by shift pi times by 8 squared, and this will give me an answer in terms of pi, hopefully. Yeah. So 32 over 5 pi, and then using pi, so as a decimal, 33.5. Dot, dot, dot. Show that I've not rounded and then round. So I'm going to go 33.5 centimeters squared. So let me write. There we go. Okay, use Pythagoras' theorem to find both of the possible values of the missing side of a right-angled triangle with sides of 9 centimeters and 12 centimeters. So for this, what I'm going to do is I'm first of all going to assume that I'm finding the hypotenuse, and then I'm going to assume that I'm finding one of the shorter sides, and that the 12 is the hypotenuse. So either I'll call it first side x. So either x is going to be equal to the square root of 12 squared plus 9 squared. So that would be the square root of 12 squared plus 9 squared. So it's either 15, or if it was the shorter side, it would be equal to the square root of 12 squared minus 9 squared. And then I'm just going to replay and change that plus to a minus. So 3 root 7, we'll put that for now. 3 root 7, and then we'll go decimal. So 7.937 dot dot dot. So 7.9. And these are centimeters, so we'll put the unit in as well. Okay, the volume of a cylinder is 500 centimeters cubed. If the radius is 5 centimeters, calculate its height to use. So we won't use pi as that because we've got a calculator. So the volume of a cylinder is equal to the area of the circle, so pi r squared, times by h. So if we're told that that's 500, 500 is going to be equal to pi times by 5 squared times by h. So just rearrange, and then h is going to be equal to 500 divided by 5 squared times by pi. So 500 over 5 squared times shift pi. So 6.366 dot dot dot. So I'm going to say, actually, I will go 6.366. The reason I've gone that accurate is if I was being, I always like to go either one significant figure more than the question or one decimal place more, and I'm arguing to myself that that's to 3 significant figures, so I've gone to 4 significant figures. Okay, a scale drawing has a scale of 1 to 200, so that means 1 of whatever unit in real life is equal to 200 in the, 1 on the drawing is 200 in real life. If a building is 40 meters tall, how tall is it in the drawing? What I'm going to do is I'm going to convert that into centimeters. So 40 meters is going to be 4,000. So times, yeah, 4,000. So 40 meters is going to be equal to 4. Let's give myself a bit more space here. 40 meters is equal to 40 with 2 zeros, so 4,000 centimeters. So if we're using a scale of 1 to 200, if I'm looking at 4,000, I'm going to be timesing by 20. So let's just double check that though. So divided by 200 is going to be 20, so it would be 20 centimeters. So 20 centimeters. The perimeter of a rectangle is 48 centimeters and its length is 14 centimeters. Find its width. So all the way around the outside is equal to 48. So we've got 14 there, and we've got x there, let's say. So if we just take half of it, so x plus 14 is going to be equal to half of this, so 24. So x must be equal to 10 centimeters. Okay, and final row. The probability it rains tomorrow is 0.75. What is the probability that it will not rain tomorrow? So, though it will either rain or it won't rain. So we're going to go 0.1 minus 0.75 is going to be 0.25. A box contains 5 red, 4 blue, and 6 green balls. A ball is picked at random. What is the probability that it is not green? So probability of it not being green. So I'm going to say P G dash to say the complement of G. So the number of not green balls we've got is 9, and the number of balls that we've got is 15. It's going to be, if I cancel down by 3, 3 over 5. Which would be absolutely fine, or we could go 0.6 or 60%. Class of 30 students took a test. The mean score was 72. What was the total sum of all their scores? Okay, so if the mean was 72, we can kind of view it like this. Mean would be equal to total divided by 30. So if the mean is 72, so 72 times by 30 would be equal to the total. So in this case, the total would be 72 times by 30. So their total scores are going to be 2,160. Okay, number of hours students revise per week is recorded. What type of data is this? Qualitative, discrete, or continuous? The number of hours. So this is kind of how we would view this. Um, an argument for it being discrete or continuous. I'm going to assume that we can have values such as, if it said the number of full hours students revise per week is recorded, what type of data is this? But I'm going to assume that we can have, like, say 2.5 hours or 2.4 hours. So I'm going to go continuous. However, I could see an argument for it being discrete if it was the number of full hours students revise per week is recorded. So a scatter diagram shows a strong negative correlation between two variables. What does this suggest about their relationship? As one increases, the other decreases. So one increases, the decreases. Okay, I hope you found that useful, and that's the end of that sheet. So good luck with your exam.